Hello, my name is Janet, and today we're going to look at additions of integers. But for now, we're going to review integers before we head on to it. Integers. Integers are the set of I in which they can be -2, -1, 0, 1, 2, 3, all the way to positive infinity, all the way down to negative infinity. The opposite, or well, what this negative sign means. This negative sign here essentially says the opposite of the number that's next to the minus. So in this case, 2. What is the opposite of positive 2? Yes, it is -2. And we can use this number graph, that's our visual aid. The opposite of positive 2 is -2. Now let's look at the next example. This minus sign out here is saying the opposite of, what number is here? -3 is what? What's the opposite of -3? You can use this graph or this number line to aid you. Exactly. The opposite of -3 is positive 3. Absolute value. Absolute value is the distance between the number and 0. Let's get our first example. Let's use 1. What is this trying to say? Well, it's trying to tell us that the distance between positive one and 0 is 1 unit. Let's see if this is true. We're going to start at positive 1, and we're going to count how many hops it takes to reach 0. 1. Look at that, 1 hop, or 1 unit. It took 1 hop to reach 0. Let's go ahead and do another one. Do the absolute value of -5. This is trying to say the distance, and if you can, while watching this video, fill it in first before me, or write it along with me, the distance between positive or negative? Negative. -5 and 0 is what? Let's use the number line. We're going to start at -5 and we're going to hop all the way down to 0. So that's 1, 2, 3, 4, 5. Let's draw this out. Took 1 hop, 2 hops, 3 hops, 4 hops, 5 hops, or 5 units. And would you look at that? It's the same numerical value, but opposite sign. This is a positive 5 and negative 5. What do you think that is? Why is this absolute value negative 5 equal to, remember, is same thing as saying equal to 5? Why is that? Well, look at the number graph. We counted, right? We didn't say -1 hop or -2 hops. No, we just said 1, 2, 3, 4, 5. So that means whatever number or integer you place within these absolute value sign is always going to be its positive form. Just like that 1. Our absolute value 1, is 1, positive 1. Do you see this? Interesting, ain't it? Let's do one more example. Let's put a negative outside the absolute value. Let's do -2. So the negative of absolute value -2, or absolute -2. Feel free to pause and try to fill it in on your own. If not, let me just guide you through this. Well, what is this absolute value saying? Well, it's saying the distance between, oops, that's a P, there you go, between positive, negative, -2 and 0 is, well, if it would just without the negative sign, this would have been 2. However, with this negative sign here, it's saying the opposite distance between -2 and 0 is what? So if we pretended this wasn't there, our answer would have been 2, right? So what's the opposite of positive 2? Exactly. -2. You think, what? Why? Well, why? Well, remember this equation I just wrote down? Absolute value -5 is equal to 5. And like we just said, if this negative did not exist, the answer would have been 2. So in like equation format, negative parentheses -2 would have been simplified to negative times positive 2. Therefore, would have been -2. Because we're saying the opposite of positive 2, and the opposite of positive 2 is -2. Not so bad, ain't it? Now, we can move on to the definition of adding integers. Future me here, I forgot to write down that I'll let m and n be any integers as described for each definition. The first definition, if m is any integers, it's any integer, then 0 plus m is equal to m, which is equal to m plus 0. Now let's deconstruct this. If m, our letter m, is equal sign any integer, how do we describe integers? As a set. Well, the set of I. So m is equal to big I. Then 0 plus m should equal to m. And that m, this m right here, should also equal to m plus 0. Well, what numbers is in the set of integers? What is in the set? We got -2, -1, 0, 1, 2, 3, -4, -3, -5, -6, +10. List goes on. So let's set m equal to, make it 1. So is 1 an integer? Yes. So 0 plus 1 should equal to 1, but it should also equal to 1 plus 0. Is this true? Well, what's 0 plus 1? 1. And what's 1 plus 0? Also 1. Do these equal to 1? Yep. So that works. It says any integer. So let's see if this works with its negative counterpart. Let's set m to be -1 this time. So 0 plus -1 should equal to -1, which should also equal to -1 plus 0. Well, what's 0 plus -1? -1. What's -1 plus 0? -1. Do these negative ones equal to -1? Yes. So, if this help made sense of this statement, perfect. On to the next definition. If m is greater than or equal to 0, and n, new variable n, is greater than or equal to 0 as well, then m plus n is defined using the addition. That was a very sad drum roll, I'm sorry. Addition of whole numbers. That is pretty easy. All we have to do is satisfy the prerequisites and see if it gives us m plus n. Let's set m to equal to 5. Is 5 greater than or equal to 0? Yes. So that should work. Let's set n equal to 0. 0 is greater than or equal to 0. Yes, 0 is equal to 0. Then m, which is 5, plus 0 is defined using addition of whole numbers. Hey, would you look at that? It looks just like any other addition problems under the addition of whole numbers section, ain't it? And the only catch here is it has to be greater than 0, so 1 and beyond, so 1, 2, 3, 4 and beyond, or equal to 0, so just 0. That's its limit. 0. Can't be -1, -2, -3, and so on. And that is incorrect. Alright, it's time to correct this. Integers is described as having negative and positive numbers. Here I'm writing that integer I have negative and positive numbers, slowly but surely. Here, let's say that m is equal to negative 3, and n is going to equal to negative 6. Now then, we're going to follow this. I'm saying that 3 is bigger than 0 because n is bigger, or 6 is bigger than 0. We're not looking at the actual symbolic or the positive negative. We're looking at the absolute value of these numbers. So now following the rule, negative 3 plus negative 6 is negative 9. Drawing our little charge field, I'm going to add in our 3 negatives. And now I'm going to add in our 6 negatives. In total, what do we have? We have a total of 9 negative charges. So, integers, negative numbers and positive numbers qualify for this definition. Let's move on to C. If m is greater than or equal to 0, and n is greater than or equal to 0 as well, then negative m, then negative m plus negative n should equal to negative parentheses m plus n. Let's deconstruct this statement as well. So if m is greater than or equal to 0, and n is greater than or equal to 0, then negative m plus negative n is equal to negative parentheses m plus n. Doesn't this prerequisite here and this m plus m, n plus n look similar to the previous one? Well, yes it does. So let's use the same numbers as before. M should equal to 5, n should equal to 0. That means, hold on. There can't be any negative 0. Negative 0 doesn't exist. So let's change the n to 1. So that means negative, let me make this pink, negative 5 plus negative 1, excuse me, should equal to negative parentheses m, did it again, 5 plus 1. Think for a moment. Is this true? Pause the video and try to solve it for yourself. Let's go ahead and work this out together. Negative 5 plus negative 1. What do you think that is? If you're having a little bit of trouble, let's make a little image to represent this. we have negative 5 little negative signs or charges, and we have 1 other negative charge. Tell me, how many negative charges are there in total? Exactly, negative 6. So negative 5 plus, in addition with negative 1 equals to negative 6. We pretty much added 1 new negative charge into this field. Should equal to, well, what's 5 plus 1? 6. Remember this? What does this mean? It means the opposite of 6. I'm gonna go ahead and make it short. The opposite of 6 is negative 6. Negative 6. Does negative 6 equal to negative 6? Yes. That works. So let's say you want to do this, you want to test this out, but instead use or make m the same, but n a negative 1. I want you to look at this, look at these two, work on your own and tell me, would this work or would it not work? And write down your thoughts to why it would or wouldn't. Pause the video. Okay, let's see if this would work or not. Well, if m is greater than or equal to 0, well, 5 is greater than 0, so that checks out. Is negative 1 greater than or equal to 0? Let's refer back to that number line, yeah? Is negative 1 greater than 0? Or how about this? Is negative 1 in front of 0 or behind 0? Behind 0. Therefore, negative 1 is less than 0. And in our prerequisite, it says that n must be greater than or at least equal to 0. So this n equals negative 1 does not work. Therefore, little circle triangular means therefore, it does not qualify for this definition. And if you're still adamant that this could possibly work, let's go ahead and plug it into the equation and see what we get. So we have a negative m, so negative 5, plus negative parentheses negative 1, which should equal to negative parentheses 5 plus negative 1. What does this say? The opposite of negative 1 is 1. So negative 5 plus 1 gives me negative 4. Go ahead and erase this for room. Actually, no, I don't want to erase. Let me put this over here. Bump this up here. There we go. Now we have room, which is equal to, well, what's 5 plus negative 1? Wait, what? Yes, 5 plus negative 1 negative, no, positive 4. That shouldn't have worked. That shouldn't have worked. I'm just gonna pretend this never happened. On to the next definition. D. If n is greater than 0 and m is greater than or equal to n, then then m plus negative n is equal to negative n plus m, which is equal to m minus n. And what is this trying to tell us? If n is greater than 0, and m is greater than or equal to n, so m is bigger, and m's number value is bigger than n, then m plus n, negative n, is equal to negative n plus m, which is the same thing as saying m minus n. Let's test this out. Let's make n to be 2 and m to be 6. 2 is bigger than 0, right? Yes. Oh, there's no bar here, so it cannot equal to 0. Is m bigger than n? Well, is 6 bigger than or equal to 2? Yes. With those two satisfied, let's see this definition. So 6 plus negative 2 should be the same as saying negative 2 plus 6, which should also be the same as saying 6 minus 2. Well, you know what 6 minus 2 is, right? It's just 4. What about negative 2 plus 6? If you're having a little bit of trouble, let's draw another charge field. So plus 6, that means we have a positive, we have 6 positives. 1, 2, 3, 4, 5, 6. And we are trying to take away, we are taking away 2 negatives, 1, 2. Now, let's see how many cancels each other out. These two cancels, and these two cancels. How many charges, number value wise, are left? We got 1, 2, 3, 4. 4 charges left. Are these positive or negative? Positive. So we leave that 4 as is. Same thing here. 6 plus negative 2. What do you think? We have 6 charges, positive charges, and 2 negative charges. Exactly. We're going to have another 4. Do these 4 equal to each other? Yes. So no matter what, if you're writing it as 6 plus negative 2, or negative 2 plus 6, or 6 minus 2, or any other numbers, you will always get the same answer, no matter what order you get. Granted, if you assign the correct symbol. Because if you accidentally assign this 6 for a negative, then that becomes a negative 8 rather than a 4, and that just completely throws it off. So please be very careful of how you're writing your symbols. Alright, next we are at the last one. Woo. If n is greater than m, and m is greater than or equal to 0, then m plus negative n is equal to negative n plus m, which is equal to negative parentheses n minus m. This looks a lot like this definition, don't it? But n must be greater than m, and m must be greater than or equal to 0. So let's assign a number to m. Let's make m 8. And n must be greater than m. Let's make that one 12. No. Yeah, 12. Let's do 12. Make it easy and fast. Is m greater than or equal to 0? Yes. Is n greater than m? Yes. So let's move on. That means 12 plus negative 8 is equal to negative 8 plus 12, which is equal to negative parentheses 12 minus 8. Let's see if they all have the same solution. Well, what's 12 take away or added a negative 8? Take away 8. Exactly. 4. Positive or negative? Positive. Leave that one as is. Same thing here. What's 8, negative 8, in addition to a positive 12? Exactly. Positive 4. Now here. Well, what's 12 minus 8? Okay. Hmm. Okay. I knew that was wrong. No, there is a typo. Let m and n be any integers as that's when it works because it says any integer and any integer. Future me once again. This time let's set n to be -1. Following the equation, -5 plus negative parentheses -1 and parentheses should equal to negative parentheses m plus n, which would be 5 plus should be -1. I'll correct that in a little bit. -1 with a negative sign outside of it is the same thing as saying the opposite of -1. And what's the opposite of -1? +1. There we go. Corrected that one. So -5 plus 1 gives you -4. Same thing. We got 5 plus -1. That's +4. And since that negative is outside, that becomes -4. -4 is equal to -4. We're good to go. As you see me waving my little pointer around, thinking that it is recording my voice as I was writing, which it wasn't, basically saying the absolute value, not the negative minus value. D. If n is greater than 0 and m is greater than or equal to n, then then m plus -n is equal to -n plus m, which is equal to m minus n. And what is this trying to tell us? If n is greater than 0, and m is greater than or equal to n, so m is bigger, and m's number value is bigger than n, then m plus n, negative n, is equal to negative n plus m, which is the same thing as saying m minus n. Let's test this out. Let's make n to be 2 and m to be 6. 2 is bigger than 0, right? Yes. Oh, there's no bar here, so it cannot equal to 0. M bigger than n. Well, is 6 bigger than or equal to 2? Yes. With those two satisfied, let's see this definition. So 6 plus -2 should be the same as saying -2 plus 6, which should also be the same as saying 6 minus 2. Well, you know what 6 minus 2 is, right? is just 4. What about negative 2 plus 6? If you're having a little bit of trouble, let's draw another charge field. So plus 6, that means we have a positive, we have 6 positives. 1, 2, 3, 4, 5, 6. And we are trying to take away, we are taking away 2 negatives, 1, 2. Now, let's see how many cancels each other out. These 2 cancels, and these 2 cancels. How many charges, number value wise, are left? We got 1, 2, 3, 4. 4 charges left. Are these positive or negative? Positive. So we leave that 4 as is. Same thing here. 6 plus negative 2. What do you think? We have 6 charges, positive charges, and 2 negative charges. Exactly. We're going to have another 4. Do these 4 equal to each other? Yes. So no matter what, if you're writing it as 6 plus negative 2, or negative 2 plus 6, or 6 minus 2, or any other numbers, you will always get the same answer, no matter what order you get. Granted, if you assign the correct symbol. If we were to set n to 2 and m to negative 3, we are going to follow n must be greater than 0. The absolute value of n must be greater than 0. 2, the absolute value of 2 is 2. 2 is greater than 0. Therefore, that works. Where m must be greater than or equal to n. So the absolute value of m must be greater than or equal to the absolute value of n. The absolute value of negative 3 is 3. And 3 is bigger than 2. So that checks out. So we're going to follow the equation. So negative 3 plus negative 2 equals to negative 2 plus negative 3. This is equal to negative 3 minus 2. I'm putting the negative 3 because m here is equal to negative 3. That's why I'm putting the negative sign next to 3. Now let's solve. Negative 3 plus negative 2. We're adding 3 negative charges with another 2 negative charges. So that gives me a total of negative 5. Same thing here. I'm adding 2 negative charges to a group of 3 negative charges. So that's another negative 5. Now to the last one. Negative 3 minus 2 is the same thing. Negative 5. Remember, integers relates to a negative and a positive number. Alright. On to the next one. If n is greater than m and m is greater than or equal to 0, then m plus negative n is equal to negative n plus m, which is equal to negative parentheses n minus m parentheses. Let's do that. Let's set m to 8 and n to 12. N must be greater than m. 12 is bigger than 8. M must be greater than or equal to 0. 8 is bigger than 0. So we're good. Now let's fill in the equation. 8 plus negative 12 must equal to negative 12 plus 8, which would equal to negative parentheses 12 minus 8. Alright, what's the opposite of positive 12? Negative 12. So this is actually 8 minus 12, or 8 plus negative 12. 8 4 should be negative 4. Let me just double check real quick. Yep, negative 4. Same thing here. Negative 12. The opposite of positive 12 is negative 12. So once again, negative 12 plus 8. That is also negative 4, which is equal to 12 minus 8. That becomes a positive 4. But don't forget, we have that negative sign there. So what's the opposite of positive 4? Negative 4. And that checks out. Let's see what would happen if we changed. Let's change the 8. Let's change the 8 to a negative. So negative 8 plus negative parentheses 12 equals to negative parentheses 12 plus negative 8 equals to parentheses 12 minus negative 8. Well, 12, negative 12 plus negative 8, we're simply just adding. We're simply adding them together. Because I'm adding 8 additional negative charges to a group of already 12 charges, negative charges. So that becomes negative 20. Same thing here. Negative 12 plus negative 8, adding on to another group of negative charges, negative 20 as well. Here, 12 minus negative 8 is saying, don't forget that this is saying the opposite of negative 8 is positive 8. So positive 12 plus positive 8 gives me 20. With that negative outside, that changes it into a negative 20. And boom, it all works. Good night.